Hi guys, yeah, this time I want to look for an affordable way to fight the heat that's currently creeping on them. And yeah, I have good experience with the PC fan, and therefore I bought this one, and that's for a reason. It's because it has a clever bearing design, which gives a long life, I think so. And yeah, but the main reason is that it pumps 90.1 cubic meters per hour of air through it. So it has a pretty good airflow, 53 CFM, and it just generates 0.3 zone as a noise level. So it's really silent, and it's also pumping a lot of air as I want it.
And if I compare it to a silent version of the fan, we see we have just 41 cubic meters per hour and 0.08 zone. So yeah, I mean 0.08 zone is pretty low. That's what I have to admit. But I mean, even 0.3 zone, if I calculate this to dB, it is just 10.6 dB. And 10 dB is even more silent than a silent refrigerator. So for me, it doesn't have to be more silent.
So let's have a look. Okay, they provide screws here. Okay, yeah, I think it's used to mount the fan directly to the PC chassis, but I do not use them, I think. Because I want to use it as a freestanding fan. But the thing is, of course, it's a pretty long object, and I mean, if you put it like this and you then tip it, you can see it easily tips over, or tends to tip over. So I mean, it would work, but it needs some kind of stand or something like this to make it more stable. And my intention is to construct and 3D print a stand where this fan here fits in. But to do that, I have to first measure the dimensions here. Okay, I have my caliper here. Let's see. What do we get here? So that's 119.3. 119.3. Okay. Okay, and the depth, that's 24.4. 24. Okay, is it the same here on that side? Yeah, so 24.4. 24.4. And as you see, the fan blades go pretty close to the rim here. So the stand has to make sure that this area is nearly free. So the stand just can have a minimum depth here, or height, and yeah, the massive parts just go here and here, so that it is like, yeah, like so, like a U-shaped stand or so. And yeah, I want to do it that way that it's, yeah, hold by friction. I don't want to screw it or something like that. It's not necessary, I think. If I make the fit pretty tight, I think there's enough friction force to hold it. So I have to start constructing. Okay, in the 3D CAD software, I start by building a rectangular block. This block must dimensionally cover all parts of the stand. Then I cut out the section where the fan has to slide in. To have a really tight fit, I use directly the dimensions of the fan without free play. That is the side wall. There must be a round cutout so the airflow of the fan is not blocked. I measured 116 mm at the round opening of the fan, so I take this as the cutout diameter. Then I extrude that circle and cut out the corresponding volume of the cylinder. And voila! There we have the cutout, nice and round. Now I have to fill up the cavity to have material to work with. Then I construct a rectangle with a long side of 90 mm and I extrude it and cut out this block. So we have two platforms where the fan can sit on, and we have a cavity which saves filament and makes it possible to fill it with steel plates or similar to make it heavier. As 3D printers usually cannot print really sharp corners, I make round cutouts on all four edges, so the fit is not ruined. The design is almost finished. My last step is to put a radius on some of the edges to give it a more pleasing look. Done! Okay, and there we have it. Looks pretty nice. Yeah, like in the 3D design tool. So yeah, let's slice that. Yeah, that's also nice. Here we see the rest ring here, the steps, but I think that's fine. I hope it will not look harsh or that harsh like it is here in the reprint now later on. And yeah, the only thing I want to change is here the scale factor. I add 0.2% and slice it again just to compensate the shrinking of the print, because yeah, otherwise I don't think that the fan will fit inside. So you see here we have now a size in the X direction of 129.56, and originally it is 129.3. So we have 0.3 millimeter additional width and length inside, and I hope that that will help that it fits later on. Now up to the printing. That is the file for the 120mm fan to be printed. Yay! the print has started. The first layer is the floor of the object. The floor has several layers, so it takes some time to print it. But as you see, the floor grows bit by bit. Here you see how the middle platform is printed. That is the infill pattern I have selected. It's called adaptive cubic, and I think due to the straight lines, this infill is easily printable and reduces the printing time. I think it gives the object also a good rigidity without adding too much mass and cost. For me, it also looks pleasing. You see how quick the fillings of the side walls are printed? I think I like this type of filling pattern and will continue to test it. Here you see the ironing of the visible middle platform surface. This is a pretty slow process, but gives a much smoother surface. The setting improver is here. I think I will not use the setting on a day-to-day basis, but when I print end-user-like parts. After about 2.5 hours of printing, this is the growing object. Quite pleasing to me to see this. This is the biggest object that I have started to print so far. If my dimensions are wrong, the print would be a waste of time and money. You also see that the side platforms are almost finished already. This is where the fan later sits on. After 3 hours and 50 minutes, we have 98% of progress. Oh, here it's clearly visible that I have slight issues with stringing. I have tried several different settings before, but was not able to solve it. It occurs only with this PLA Plus that I currently use. But it is no showstopper for me, as it won't reduce the usability in this case. Yay, the print is ready after 3 hours and 55 minutes. I switch off the heating and raise the printhead to make room for the detachment of the object. The heat pad has now cooled down completely. Let's see how good the object detaches now. Oh, it has detached itself already. Good. Okay guys, yeah, I already pushed the fan inside the socket. It is a really tight fit as I designed it. And the 2% add-on in the Prusa tool for compensating the shrinking of the PLA Plus material is pretty accurate, as I have seen now. Yeah, and I have seen that I just missed that the diameter here is larger on this side compared to this side, because you see here it's a really good fit, and here it blocks the airflow minimally. I don't think that this is a showstopper, but in a second print I would change that. And I already discovered that if I now push the fan on the upper side here, I can push it pretty far and it bounces back. And that was not possible before the fan was in the socket, so obviously the socket improves pretty good. So the design is a full success, and as the socket has been printed pretty massive, because I have set the prusa tool to print several layers, or at least 4 layers here for rigidity. The socket has quite a mess, so that helps to bring down the center of mass. So if you like that design here, you can, and you are interested in the step file for the socket, just donate €5 or $5, and then I will send you the step file. I think I will kind of end that video here. So I think I have shown you how I design it from the idea and to the final print. And if you're not already a valued subscriber, you have now the chance to become one. Write a nice comment if you are also in 3D printing actually. And I will see you next time. Bye bye.